please tell us your name and tell us about your project.
My name is Sir Arthur Eddington. I'm an English astrophysicist. Just a little bit about myself. I attended Trinity College, which is a constituent college of the University of Cambridge, and I'm a Quaker pacifist, advocating for the scientific community to remain united during World War I. These views are part of what motivated me to confirm German physicist Albert Einstein's general theory of relativity, which is directly related to our project. Our project involved expeditions to measure the bending of light from distant stars around the sun. Celestial bodies like our sun are thought to cause space-time to curve slightly, and Einstein's general theory of relativity predicted light would bend slightly following these curves in space-time. This differed only by magnitude from Isaac Newton's predictions, which were twice as much as Einstein's. Our measurements were taken during the total solar eclipse of May 1919 with two tandem expeditions, and we set these two locations as insurance of sorts. In the event of bad weather or other unforeseen circumstances, we would still be able to gather our required information.
Okay, what were you trying to do or trying to find?
Our project was meant to confirm one of the key predictions of Einstein's general theory of relativity, namely the degree at which light would bend around celestial bodies. Each expedition took photographs of a certain region of the sky, centered on the sun during the May 1919 solar eclipse. And these were compared to photographs taken in the same positions of stars in the night sky. The results confirmed the deflection of light and that it was consistent with Einstein's theory of general relativity, but not with the Newtonian physics.
Where did this project or experiment occur?
Again, for fear of bad weather or other unforeseen circumstances, we had two separate expeditions for the same eclipse. One was to the West African island of Prince Pei. This one initially started off a bit rough. We had some heavy rains the day of the eclipse, but our enthusiasm was restored with the clearing of the skies just in time for us to take our measurements. The contingent expedition to a Brazilian town called Sobral, they also had some trials of their own. The intense tropical heat actually warped their larger telescopes, so they had to revert to using smaller 10-centimeter instruments that they'd carried as backup.
What other significant events are happening around the world at this time?
There were many significant events happening. One such event was a few years later, in 1925, Edwin Hubble, an American astronomer, he performed some experiments measuring the period of certain stars' fluctuations in their brightness. And doing that, he could calculate their distance. He did this and proved that nebulae are much too distant to be part of our galaxy. And rather than gas clouds within our own galaxy, they are actually entire galaxies of their own outside of the Milky Way. This settled the great debate at the time about the nature of spiral nebula as well as the size of the universe. Also, more directly related to our venture, 1916, Albert Einstein published his general theory of relativity, which again describes gravity as a property of the curvature of four-dimensional spacetime. Like our Earth, it follows its curved path under its own inertia through warped spacetime due to the fact that this is the shortest distance possible in warped space. Also, World War I had an effect on everything, even our expedition. We ran into a few delays with the manufacturing of our instruments due to the fact that manufacturing facilities were inundated with work pertaining to the war. But the war ended in November of 1918 and we were able to progress.
Who else was involved in this project?
Sir Frank Dyson was a major contributor. He's an astronomer royal in the royal houses of the United Kingdom, and he studied mathematics and astronomy as well at Trinity University. He was the first to propose the expedition to view the total solar eclipse in May of 1919.
And what was your role in this project?
Well, in the beginning of 1919, January and February, Prior to the expedition, I took baseline measurements of the positions of the stars in the Hades cluster, which is part of the constellation, the Taurus constellation. And then in May of 1919, I led the leg of the expedition to Prince Pay off the coast of west coast of Africa, where we made our observations during the solar eclipse. I used this information along with the baseline measurements to verify Einstein's theory. Upon return, I presented our findings to the Royal Society of London.
And what impact did your project have on the physics community?
It was a very large impact. Although at first it was conflict. Not everyone immediately accepted the findings, and doubts of the accuracy of the data, given the limitations of our instruments, arose. And even some accusations of foul play regarding the gathering of the data. All of this was put to rest, though, in 1922, when a separate team of astronomers also did this experiment and had similar findings. Again, overall, the impact was huge. We validated one of the key predictions of Einstein's general theory of relativity, which is much more than a slight improvement over Newton's universe. In fact, it's a whole new way of looking at the universe. You can visualize it as bodies telling space and time how to curve, and correspondingly the curving of space and time telling bodies how to move.
Thank you for your time, Sir Eddington. Is there anything else that you would like to add in closing?
Although I am a man of science, I do also have other facets. So I'd like to leave you with this lyrical parody I've penned. Oh, leave the wise our measurements to collate. One thing at least is certain, light has weight. One thing is certain, and the rest debate. Light rays, when near the sun, do not go straight.